In this one, we're supposed to graph the equation, and we're supposed to find any local or absolute or global extreme points and inflection points. So here is the function we're given. We're going to go for the critical points. So set y prime equal to 0, factor it out, work it out, and get x equal 1, x equals 2 are the critical points. Perform the second derivative test to see if they're local max or min. Get your y double prime at x equals 2. Y double prime is greater than 0. So you have this concave up look for a local minimum at x equal 2. At x equal 1, y double prime is less than 0. So you have a concave down illustration, and therefore a local max at x equal 1. Now there are no global extreme points this time, because as we'll see on the graph on the next page, and the fact that this is a cubic polynomial which goes on to infinity to the right and negative infinity to the left, so there is no global extreme points. Then we go for the inflection points. An inflection point is a change in concavity, going from concave down to concave up across the point, or vice versa. So since it goes from concave up to down or down to up, it has to go through 0. So if f has an inflection point at x0, then it's 100% certain that f double prime at x0 will equal 0 there. But not the other way around. If f double prime at a point equals 0, then there just could be an inflection point at x0. But that's the only tool we have, so we have to set the second derivative equal to 0 just to see if there are any possible inflection points. Then we have to test them to see if they really are inflection points. So we set the second derivative equal to 0, and it comes out to be x equals 3/2. But we have to test it. You really must test that point. You don't know 100% whether that's an inflection point yet or not. So to see if it changes concavity, we're going to go from left of the point to right of the point. So going f double prime evaluated to the left of 3/2, you pick some convenient point like 1. That's to the left of 3/2. Evaluate it into f double prime, which we've been calling it y double prime, but in general it's f, and that comes out negative. Whereas if you test to the right of 3/2 at, say, a convenient point like 2, then when you evaluate that into f double prime, it comes out greater than 0. So there definitely is a change going across 3/2 of the original function being concave down to the left of the point, moving to concave up on the right of the point. So yes, there is a change in concavity at x equals 3/2. Therefore, there will be an inflection point at x equals 3/2. So then we go and finish off what the question asks for. It asks for evaluating and finding the actual points. So you do have 1, 5 at x equals 1, and we do see that that indeed is a local max point, level point, and local max at 1, and the extreme value there of f is 5. Then we do have our inflection point, and see how it looks. It's concave down. The slopes coming from the left are decreasing, even becoming negative, and decreasing, getting more negative until this point right there. Now all of a sudden the slopes are negative, but they're less negative, turning the corner to give you a concave uplift. So this is concave down and then concave up. And that's why there's an inflection point at 3/2. And then the other local extreme point is at x equals 2, level right here, and the extreme value of that local minimum is f of x equals 4.